Hey y'all, today I want to go ahead and take a look at Lesson 12.1 Notes, Surface Area, and Volume of Prisms and Cylinders. Now let's go ahead and discuss parts of a prism. Two parallel congruent faces of a polyhedron means 3D, we call those two parallel congruent faces the bases of a prism. So let's go ahead and take a look at these two prisms here. We have a right prism because we can see there's a 90-degree angle, and then we have an oblique prism, which is a prism whose base and lateral faces are not perpendicular. So this here and this, those are parallel and congruent to each other. We call those two faces the bases. And over here, this and this, they are parallel to each other and also congruent to each other. So those two faces are bases as well. The faces that are not the bases are the lateral faces. So we know that these two faces here are the bases, but the lateral faces are not the bases. So basically what I'm trying to say is that everything else. I'm talking about this, and over here, this as well, and also the back side. Those are the lateral faces. So looking at this specifically, it's pointing at this face. That's an example of a lateral face for a right prism. For an oblique prism, it should be the same thing. This is a lateral face. And we know that these two things here are the bases. So again, a lateral face is not a base. The lateral edge is where the lateral faces intersect. So we can see that this face and this face, they intersect at this particular edge. We call that the lateral edge. And this is also the lateral edge, because this face here and this face here, they intersect at this particular edge. Now, the base edge is where the lateral faces intersect the bases. Okay, this base and also this side over here, that lateral face, intersects at this particular edge, okay? Or I could say, if we want to be more clear, this is a lateral face. This is my base here, and they intersect at this particular edge. We call that the base edge. So this face and this base, they intersect at this particular edge. We call that the base edge. The altitude is a perpendicular segment that joins the planes of the bases. So this segment here, they intersect these two bases, right? So this segment intersects here at a 90-degree angle and here at a 90-degree angle. That particular segment is what we call the altitude. So I can also say that this is the altitude. And then over here, this is the base edge. And then this, remember, it's an oblique prism is a prism whose base and lateral faces are not perpendicular to each other. But if it was a right prism, then this would be the altitude. And to give a measure or length of the altitude, we call it the height. Okay, so we can also call this the height if we give it a number. Okay, so those are parts of a prism. The next thing I want to go ahead and discuss is the lateral area. How do we find the lateral area of a prism? The lateral area is the sum of the areas of the lateral faces. Now remember, the lateral faces are the faces that are not the bases. So if I'm looking at this prism here, remember, a prism is basically this. You have two congruent faces that are parallel to each other. And typically they are separated by the height or the altitude. Now, these two things, the top and bottom parts of this particular prism, those are my bases. To find the lateral area, you need to find the area of this plus this and also the backside. But I think it would be better if I were to, take this object and open it up. And this is the result. We call this particular object a net. A net is what a three-dimensional shape would look like if it was opened out and laid out flat. So if I opened this prism, I get something like this, right? You can see that these two things are the bases and these are the faces. And just by looking at the lateral faces, this kind of reminds me of a rectangle, right? And if I want to find the area, well, I have a rectangle here. All I need to do is I'm going to do this. I'm going to add up the sides, which is the base, and I'm going to multiply that by the height, right? So whatever this is plus this, take that result and multiply that by the height, which will give you the area of this rectangle. That's basically the lateral area. The lateral area of a prism or a right prism is the product of the height, h, of the prism and the perimeter, p, of a base. So this is the formula that you need to know. The lateral area, L, is equal to the perimeter of the base multiplied by the height of the prism. Okay? So please make sure that when you are doing these problems, you gotta identify what the shape of the base is. Okay? So in terms of a prism, the prism's bases are usually separated by the height. So I know for sure that these two things are the bases because, one, they are congruent parallel faces separated by the height here. Okay? So I can say that this is a triangular prism. So let's take a look at example 1 together. Find the lateral area of the prism, round to the nearest tenth. So this is what I'm going to do. I'm going to use my formula. The lateral area is equal to the perimeter of the base multiplied by the height. You want to make sure that you identify what the base is. So what is the base? So I'm going to write base, colon, and okay, I can see that we have two triangles facing each other. They're parallel to each other, and those are the two faces that, you know, are facing each other, if that makes sense. And they are separated by the height here. So the shape of these two bases, they are triangles. All right, triangle. All right. Okay. So L is equal to the perimeter of the base, so the triangle, which I'm going to redraw. So 5 centimeters there, 6 centimeters there. So I'm trying to find the perimeter of the base. And then I'm going to multiply that by the height of the prism. So, okay, let's find the perimeter of the base, which is a triangle. We currently have 5 plus 6, and I don't know what this side here is. That means I got to use Pythagorean theorem because it's a right triangle. So a squared plus b squared equals c squared. And it's going to be, what, 5 squared plus 6 squared equals c squared. I want to solve for c, so I have to take the square root on both sides. So I'm going to input all of this into my calculator, and I should get c is approximately 7.81. So I have 5 plus 6 plus 7.81, and that's going to be 18.81. Okay, so that's the perimeter of the base. And I'm going to multiply that by the height of the prism. And it's the segment that is separating the two bases. So this is what's separating the two bases. That's the height. So I input 7 there. I have 18.81 multiplied by 7. So I should get approximately 131.7 square centimeters. Because I'm dealing with area, this should be squared. So that's my answer. Now the next thing I want to go ahead and discuss is something called surface area. Surface area is the sum of the lateral area and the area of the two bases. So suppose that you have a box or a cube and you want to cover it all up. You want to wrap it up as a present. That wrapping paper is essentially the surface area. You are including the lateral faces and also the bases. You're covering everything up, therefore you're dealing with surface area. Now, surface area of a prism, the surface area S of a right prism is the sum of the lateral area, L, and the area of the two bases combined. So we denote big B or capital B. This is what we call the area of the base. So remember, you have to identify what the shape of your base is. And then you will apply the correct area formula. And once you find the area of the, base, then you're going to multiply that by 2. Why do we multiply by 2? Because we have a prism, and a prism contains 2 bases. Okay? So, to find the surface area, you need to have the lateral area, L, plus the 2 bases. Or we can say that S is equal to the perimeter of the base, multiply the height of the prism, plus 2 times the area of the base. And it says right here, to find B, the area of the base, use whichever formula applies to the shape of the base. Super important that you know this, okay? You have to differentiate big B, capital B, and lowercase b. Big B means the area of the base, okay? So I'm gonna write that again. We already said it over here, but we can also say it over here as well. Big B means area of the base of the prism. Okay, so let's go ahead and take a look at example 2. Example 2 says to identify the type of prism, hint, what is the base, and then find the surface area, round to the nearest tenth if applicable. So I want to go ahead and take a look at this shape, and it's a unique case because number one, we're trying to identify what figure this is. We have to take a look at its bases. So the bases of a prism, we look at whichever faces are facing each other, parallel to each other, congruent to each other. And the two bases generally are separated by a height, okay? But like I said, this is a unique case. Why? Because we can see that the top and bottom are parallel, congruent, and separated by a height here. We can see that the left side and the right side are parallel, congruent, and separated by a height here. We can also say that for the front side and the back side, those are parallel, congruent to each other, and separated by a height here. So for this particular prism, it's a choose your own adventure, right? Whatever you use, you will still get the same answer in terms of finding the lateral area and the surface area. Okay, so what type of prism is this? Well, we got to identify the bases, which we've already done. We've shown that there are multiple bases for this figure, but I'm going to choose one, and I'm just going to be basing my choice from the key. The top and the bottom are the bases that I'm going to be working with. Okay, once again, those two things are the bases because those are the two faces that are parallel to each other and also congruent and separated by the height here. So the height of the prism will be 6 feet, and I'm going to denote that as h, okay? So we have a rectangle. That's the base of my figure. We have, 9 feet, and we have 4 feet. So I'm just going to be looking at this. The dimensions are 9 feet, 4 feet. So let's go ahead and find the surface area. So to find the surface area, it's equal to the lateral area plus the two bases. But the lateral area is the perimeter of the base multiplied by the height plus 2 times the area of the base, okay? So let's go ahead and find the perimeter of the base. So basically, this is a rectangle, it's a parallelogram, meaning that opposite sides are congruent to each other, okay? So we have, since this is 9 feet, this is also 9 feet. And since this is 4 feet, this is 4 feet. I'm gonna add up all the sides now. So 9 plus 9 plus 4 plus 4. That's going to be 26. Okay, so it's the perimeter of the base. Now let's go ahead and find the height of the prism, not the height of the rectangle. So the height of the prism, we said it was 6. So I'll put 6 there. Plus 2 times the area of the base. So if I'm looking at the base, big B, it's a rectangle. What's the area formula for rectangle? So I'm going to write a rectangle. Its base times the height. Now please note that I'm referring to the base of this figure and the height of the same figure, not the prism, okay? I know there are two H's here. You're not going to put 6 for the height. This H is the height of the prism. This H is the height of the rectangle. So I can go ahead and just be clear there and say that I'm dealing with the base of the rectangle multiplied by the height of the rectangle. So the base of the rectangle is 9 and the height of the rectangle will be 4. So that's going to be 36. The area of the rectangle is 36. So 2 times 36, and then this is where I'm going to compute. 26 times 6 is 156, plus 2 times 36 is 72. So the surface area of this figure is 228 what? Square feet. I'm putting square feet, the exponent of 2 here, because I'm dealing with area. Okay? So that's the surface area of the prism. Now, I forgot to do something. I didn't identify the type of prism. Remember, to name the prism, we have to identify the base, which is a rectangle. So this figure is called a rectangular prism. All right. So now what I'm going to do is I'm going to look at this prism. We're going to ID the base, okay, to identify the base. So we can see that this is parallel to this. They are congruent to each other and they are facing each other. So the base, big B, so the base of the figure is a triangle. So this is what we call a triangular prism. So I'm going to draw my triangle. It's a right triangle. So 12 millimeters there and 12 millimeters there. Okay. So what do? I'm trying to find the surface area. So the surface area is equal to L plus 2B, or I can say the perimeter of the base multiplied by the height of the prism plus 2 times the area of the base. Okay, so let's find the perimeter of the base, which is a triangle. We have a right triangle, its isosceles. So that means that if this side is 12, this side is 12, then the hypotenuse is 12 root 2. And I'm using special right triangles to figure that side out. Okay, so I'm going to do 12 plus 12 plus 12 root 2. In fact, let's go ahead and just put all of this under P. So 12, let's use a different color. I want to stick with blue here. 12 plus 12 plus 12 root 2. Okay? And then we'll multiply that by the height of the prism. So remember, the height of the prism, it's the segment that separates the two bases. So this is the base, this is the base. What's separating the two bases here? It's 8. So the height of the prism is 8. So I'll put 8 right there. So I have completed this part of the formula. Now what I need to do is find this, 2b. So big B, again, big B means area of the base. So this is the base. It's a triangle, right? So the area formula for a triangle, it's A equals 1/2 base of the triangle multiplied by the height of the triangle. This H is dealing with the height of the triangle itself, not the prism, okay? So don't put 8. Use the height of this triangle. So we have 1/2 times 12 times 12, because these two segments are perpendicular to each other. So it's 1/2 of 12 multiplied by 12. So it's going to be 6 times 12. What's 6 times 12? That's 72. So 72 square millimeters, right? So I put 2 times 72, and that's 2 times the area of the base. So then I'm going to put all of this into my calculator, and you should get approximately 471.8 square millimeters. That's the surface area of this figure. Okay, so now what I want to go ahead and do is take a look at cylinders. A cylinder is a type of prism where the two bases are circles. So as we can see, this is the base, this is also the base. Those two things are facing each other, and they are separated by the height here. We don't call this a circular prism, we will call it a cylinder. That's the specific type of name. Now, parts of a cylinder. The segment that connects the two bases of a cylinder is what we call the axis. So, this segment here, well, first of all, these are the two bases, yes. These two things that connect the two bases of a cylinder, that's what we call the axis. This segment is what we call the axis. And the area of the lateral face of a cylinder will always be the lateral area, which we discussed before. And this one right here, the sum of the area of the lateral face and the two bases of a cylinder is what we call the surface area. So to find the lateral area, you're going to just work with this, except the two bases. These are the bases once again. Now, if you want to find the lateral area and the two bases combined, then what you're doing is you're trying to find the surface area. The lateral area of a cylinder. The lateral area L of a right cylinder is the product of its height. So H means height of the prism in this regard, and the circumference of a base, right? And we talked about the generic formula would be lateral area is equal to the perimeter of the base multiplied by the height. But the perimeter of a circle is 2 pi r, generally, okay? So 2 pi r is the circumference. So let's take a look at this. So if I want to turn this into a net, this is what I have. And I want to find the lateral area of the cylinder. So to do that, okay, this is my visual. The lateral area, again, is basically the stuff without the two bases. In other words, or to demonstrate, it's this figure here, which looks like a rectangle once again. So to find the area of this, it would be the base multiplied by the height. How do I find the base? Well, this is essentially this circle, right? The perimeter of the base. It's C equals 2 pi r. Once I find the perimeter, or the C equals 2 pi r, the circumference, I multiply that by the height of the prism, which is that, okay? So that's the lateral area of a cylinder. And the surface area of a cylinder, S of a right cylinder, is the sum of the lateral area and the area of both bases. So S equals the lateral area plus the two bases, or S equals 2 pi r h plus 2 pi r squared. So you're going to find the area of this plus that. Okay, so let's take a look at example 3. It says find the lateral area and the surface area of the cylinder. Leave your answer in exact terms of pi. So what's the base of the prism or the cylinder? Well, the base is a circle. These two things are facing each other, separated by the height. So I'm going to highlight the height here and put h underneath. So the lateral area, so L equals the perimeter of the base multiplied by the height. Or the perimeter of the base, so the perimeter of the base is a circle. Right? So to find the perimeter of the circle, it's basically saying you need the circumference of that circle. So I'm going to rewrite this formula here. It's going to turn into this. It's going to be L equals 2 pi r. Again, that's the perimeter multiplied by the height. So L equals 2 times pi. And I'm going to look at the radius of the circle here, which would be 7.5. All right. Again, P is the perimeter of the base. And yes, I'm going to capitalize the B for this one. Okay, so it's 2 times pi times 7.5. And you're going to multiply that by the height of the prism. So this is the height of the prism. So it's 18. So L equals, okay, we have 7.5 times 2, which is 15. I could have said pi d times h, but 2 pi r h is still the same thing. So 2 times 7.5 times 18, that's 270 pi square millimeters. Okay, we're dealing with lateral area. Make sure that you square the unit. And to find the surface area, it's basically the perimeter times the height plus 2 bases. But we already figure out that the perimeter and the height is 2 pi r h. Okay, so I can just say 2 pi r h here. All right, we've already discovered, or we already figured out what the lateral area is, right? So I don't need to do this again. All I have to do is just replace this with this. So the surface area is equal to 270 pi plus 2 times big B. So big B is the area of the base. So we're going to go back to the circle here. We're going to find the area of the base, or the area of the circle. So it's A equals pi r squared. So pi times 7.5, the quantity squared. And that is going to be 56.25. So then this is 56.25 pi. Okay, so 2 times 56.25 pi. And then let's go ahead and rewrite this. So it's 270 pi plus, what's 2 times this? That is 112.5 pi. So adding these two numbers together, I should get 382.5 pi square millimeters. So again, I square the unit because I'm dealing with area. And that's example 3. So what I want to go ahead and do now is get into the territory of volume. Volume is basically how much space is taken up inside three-dimensional objects. So if I have a glass cup and I pour some water into the glass, well, how much space does the glass contain, right? That's volume. So to calculate the volume of a prism, the volume V of a prism is the product of the height and the area of the base. So its volume equals big B. So big B is the area of the base multiplied by the height of the prism. So this is a prism. We have these two bases here. They're facing each other, separated by the height. So once you figure out the area of the base, you multiply that by the height. Now, the volume of a cylinder, the volume V of a cylinder, is the product of the height and the area of the base. So V equals BH. We already explained what big B and H are. If I look at this particular prism, which is a cylinder, the shape of the base is a circle. So if I want to find the area of the base, well, it's a circle, right? So you're going to use A equals pi r squared. And once you have the area, you got to multiply that by the height. So again, the area formula for a circle is pi r squared, and this is the height. So pi r squared times the height is how you find the volume. The volume of a rectangular prism, the volume V of a prism, is the product of the height and the area of the base. V equals BH, or let's take a look. What is the what's the shape of the base? Let's just say it's this shape. It's we're gonna say that it's a rectangle. We can't assume that that's a square, by the way. But we have this base, and we cannot forget that there's a rectangle on the back side. So I'm going to draw my figure. It's LW. So this is how you find the area of this rectangle. It's length times width, or base times height. But we're going to use length times width this time, so we don't confuse ourselves with all these B's, the letter B's. And then that's the height. So once you find the area, you're going to multiply by the height, and that's how you find the volume of a rectangular prism. And then lastly, the volume of a cube. The volume V of a prism is the product of the height and the area of the base. V equals BH, and we can assume that this is a square. Let's say that this here is our base. That's the shape of the base. It's a square. So the area of the square formula is S squared, right? So what's the height? What's separating the two bases? Well, we know that there's a front base and then there's the back base, and then it's going to be separated by the height here. So I'm going to throw in an S there. S squared times, well, this is really confusing, sorry. So the area of a square is S squared, right? So that's B. So this is B. And the height, right? So V equals S squared, that's my B. And I'll multiply that by the height, which is S. So really you get V equals S cubed, which is what you have over here. All right, now let's go ahead and take a look at example 4. Okay, so example 4 says identify the solids and find their volumes. Leave your answer in exact terms. So we have this prism here. This is a triangular prism. Why is that? Because the shape of the base is a triangle, or the shape of the bases are triangles separated by this height here. I'm gonna highlight the height, and then let's draw the shape of the base, which is a triangle. 10 here, 10 here, 12 there. So the area of the triangle is 1/2 base times height. So 1/2 of 12 times 10. So that's 60 centimeters squared, or square centimeters. And then the height is 11. So the formula that we need, or the volume formula, is V equals big B times H. So V equals, well, this is the area of the base, which is 60, right? So 60 times the height of the prism. V is equal to 660 cubic centimeters, right? Because we are in volume land, we need to make sure that our units are cubed. That's the answer for this problem. That's our triangular prism. Over here, okay, what I have here is a prism, and this is a pentagonal prism. So what I need to do here is this. To find the volume, it's big B multiplied by the height, right? So let's find the area of the base. We know for sure that the area, or I should say the shape of the base, we know that the shape of the base is a pentagon. And all the sides here are congruent to each other, right? So if this face or this base is parallel to that, and they are congruent, these side lengths here are congruent, just like what we see up top. Okay, so we can see that this is our apothem. It's what, 3.4 millimeters. And then what else do we have here? The side length here is 5, so I just put 5 there. And because all the sides are congruent, every side length gets a 5. All right, and then the height, what's the segment separating the two bases? It's this 8 here. So this is the height. So let's figure out the area of the base, the area of the pentagon. It's equal to 1/2 the apothem multiplied by the perimeter. So 1/2, and I love how the apothem is already given. It's 3.4, right? And I'm going to multiply that by my perimeter. So 5 plus 5 plus 5 plus 5 plus 5. Since the pentagon, 5 times 5 is 25. And there you go. I can figure out what the area of this pentagon is, which is 42.5, okay? So V is equal to 42.5 multiplied by the height here, which is 8. And then I get V equals 340 square, just kidding, cubic millimeters. That's your answer. That's how much space you can have for this prism. So if I pour in water, the volume is 340 cubic millimeters. Over here, what type of prism is this? Because the circles are the bases, we don't call it circular prism. We call this a cylinder. we call this a cylinder. So V equals big B times H. And we know for sure that our base is a circle. The diameter is 9, and this is the height because it's separating the two bases here. Right, so this is the height. Let's figure out the area of the circle. That's big B, that's what I'm trying to find here. So the area of the circle is equal to pi r squared. So pi times 4.5 the quantity squared, and 4.5 the quantity squared is 20.25 pi square inches. So V equals 20.25 pi times, so 20.25 pi times 5. So I need to multiply the 20.25 and the 5 together, and I get V equals 101.25 pi cubic inches. That's my answer. Now what we're going to be doing is working backwards. So here's some working backwards problems. A cylinder has a lateral area of 120 pi square meters and a height of 7 meters. Find the radius, round to the nearest tenth. So the lateral area of any prism is the perimeter times the height. The lateral area is given, it's 120 pi, which is equal to the perimeter of the base of the cylinder. Right, so if I have a cylinder, we know that the base of the cylinder is a circle. So what's the perimeter of a circle? The circumference, right? So instead of saying big P, I can just say 2 pi r. And then the height of the cylinder is 7. So I can replace H with 7. So then 2 times 7 is 14. So I have 120 pi equals 14 pi r. Divide both sides by 14 pi, because what am I doing? I gotta find the radius here. So the 14 pi's will go away, and then the pi's will cancel out over here. So 120 divided by 14 is this. The radius is approximately 8.6 meters. A right rectangular prism has a surface area, that's a typo. A right rectangular prism has a surface area of 412 square inches, a length of 7 inches, and a width of 8 inches. Find the height. Okay, so surface area formula. So the surface area formula is S equals the perimeter times the height plus the 2 bases. We have to include the bases on this one. The surface area is given. It's 412, and we're dealing with a rectangular prism. So 412 is equal to we're dealing with a right rectangular prism this time. Okay. So we know for sure that the base of a rectangular prism is a rectangle. So it has a length of 7, a width of 8, and then the height of the prism would be something like this, right? If I were to draw my rectangular prism, which I'm not really good at doing, but something like this. Alright, so this is the length, this is the width, and then this should be the height, are unknown. Okay, so the perimeter of this rectangle here, 7 plus 7 plus 8 plus 8, that is 30. So it's 30. And then I'm going to multiply that by the height of the prism, which is our unknown. That's what I'm looking for. It's h plus 2 big B's. So that's the area of the base. So the area of the base is length times width or base times height, right? So area of a rectangle is base times height. So 7 times 8 is 56. Okay, so 2 times 56, and 2 times 56 is 112. So I have 412 equals 30h plus 112. And now what I'm going to do is I'm going to subtract both sides by 112. And I get 300, which is equal to 30h. And I'm going to divide both sides by 30. So that should give me 10. So the height is 10. 10 what? 10 inches. Okay. Now I'm going to look at the last problem here. The volume of a cylinder is 754 cubic meters. The radius of the cylinder is 7 meters. Find the height. So V equals big B times H. So we're dealing with a cylinder. Man, what's up with the typos? So the shape of the base of the cylinder is a circle, and it has a radius of 7. So it has a radius of 7. So it's the volume equals the area of the base. So the area of the base is pi r squared, right? So I can replace b with pi r squared, and it's multiplied by the height. And we know what the radius is. It's 7, so it's 7 quantity squared multiplied by the height, which we still don't know. So it's equal to 49 pi h. But look at this, y'all. The volume is already given. It's 754, right? So I can put 754 here, 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 and here. And this is the equation that I am working with now. So I'm going to go ahead and solve for the desired variable. I want to solve for h this time. So I got to divide both sides by 49 pi. Those will go away. So h is equal to what? I do 754 divided by 49 pi, which is approximately 4.9, rounding to the nearest tenth here. So it's approximately 4.9 meters. And there you go. I am done with the notes.